Hello, students. Mr. Murphy here. We're going to go through the student workbook. This may take 2 or 3 videos, so stay with me. We are learning lesson 2, multiplication of numbers in exponential form. We did this right at the end, right? If any number x with the power of m multiplied x to the power of n, we're just going to add the exponents, right? So positive numbers, we add the exponents. So 14 to the power of 23 times 14 to the power of 9 would be 14 to the power of 14 would be 14 to the power of 23 plus 8, which would be 14 to the power of 31. And it doesn't matter if it's a number for the base or a letter. So if it's a variable a to the power of 23 times a to the power of 8, that would be, man, I did these all wrong. A to the power of 23 plus 8, which would be a to the power of 31, just like we did with 14. Okay. Negative 72 to the power of 10 times negative 72 to the power of 13 would be negative 72 times the power to the power of 10 plus 13, or negative 72 to the power of 23. Doesn't matter if it's negative 72 or if it's f, as long as your bases are the same. 5 to the negative 95 to the 94th power times 5 to the 78th power is 5 to the 94 plus 78th power, which is 5 to the 172nd power. Doesn't matter if it's b or if it's 5, I'm just going to add them together and find out that it's b to the 172nd power. Doesn't matter if our base is negative, we're still going to add the exponents. This one is really interesting. So if I have so x is just a positive number. So if I have negative 3 to the 9th power times negative 3 to the x power, and those equal negative 3 to the 14th power, how do I get that? Well, that would be like saying negative 3 to the 9 plus x power equals negative 3 to the 14, or just 9 plus x equals 14. So what 9 plus what number equals 14? 9, 10, 11, 12, 13, 14. So that would be 5. Or I could say 14 minus 5 if I add or subtract that way. So what would happen if there's more than 2 terms? So 9 to the 4th power times 9 to the 6th power times 9 to the 13th power. I'm just going to add those up. So that's 9 to the 4 plus 6 plus 13. If I have 4 2's, I'm just going to add them up. 2 to the 3rd times 2 to the 5th times 2 to the 7th times 2 to the 9th. I'm going to add up the exponents. 3 plus 5 plus 7 plus 9. And the answer would be 2 to the power of 5, 6, 7, 8, 17, 15, 24. That would be 2 to the 24th power. Can these expressions be written into simplest form? 6 to the 5th power times 4 to the 9th times 4 to the 3rd times 6 to the 14th. Can I simplify that? Yes. Can I simplify 6 to the 9th power times 4 to the 9th power? No. They're different bases, but I can put the ones with the same bases together. So 6 to the 5th power times 6 to the 14th power go together, and then 4 to the 9th power times 4 to the 3rd power go together. So 6 to the 5th, so that would be 5 plus 14, so that would be 6 to the 19th power times 4 to the, I've got 9 plus 3, that would be 12. 4 to the 12th power. Put my little caret in there so you know it's a 4th power. Okay? So if they have the same base, I can add them together. If it's a commutative property, I can move stuff around to get those. All right? So we have about 10 seconds left in this video. See if you can do the rest of those. And I'm going to skip to the next on the next video.